numerical integration using trapezoidal, Simpson's, 1/3 and Romberg's method. First of all, the function is y function fx. Here the upper limit we will integrate from x0 to xn. Here xn is the upper limit and x0 is lower limit. We will solve the interval into n trapezium. So the every interval will be, or step size will be h. Here h is equal xn minus x0 by n. Trapezoidal rule is this. So we have to iterate from y1 to yn minus 1 and add them all and also multiply with 2. Then we will add this term y0, y0 and yn, and overall we have to multiply h by 3. Then we will get the desired integration using trapezoidal rule. So I will do this for this example. Here the function is y equal to x square and lower limit x equal to 0, upper limit x equal 4, and number of trapezium will be 4. So n is equal 4, and we will first calculate h, then do this in a for loop, and then add this and multiply with h by 2, and we will get the answer. So here function equal, we will use function handler x square, then x naught, x 4, and number of trapezium is 4. So step size calculation. We take a variable sum equal 0. First of all, we calculate this. So iterate from y1 to yn minus 1, or 1 to n minus 1. Sum equal to 2 times. Here y1 means function value at x naught plus h. Then for y2 we have to multiply h by 2. So we can use here I. For first iteration the value of I is 1, so it matches with it. Then for second iteration it becomes 2, and we get y1, y2, y3, and 2 to sum plus sum in the end. The result will be h by 2 function value at y naught, that means function value at x naught, plus sum plus yn. So function value at xn. We run the code. Here function. This we get result 22. Here the result is 22. Now we will use input. We does not want to show this line, so we just add semicolon. analytically the answer is 21.33. We got using 22 using trapezoidal rule. When we use number of trapezium 4, if we run this code with larger value of n, we should get more accurate result. Let's say 8. It is 21.5, better than previous. For Simpson's rules, the formula is this. Here I have to multiply 4 with the odd terms and multiply with 2 with the even terms. So I will use 2 for loop, one for odd and other for even, and here I have to step from 1, 3, 5 like this. Here I have to step 2, 4, 6, and also here is one chance. I have to use h by 3, which was h by 2 for trapezoidal rule. Now in code, the code are almost similar, so I can copy that. Now first of all I have to change h by 3, and a for loop for this calculation, so I will use this for loop. Here I have to start from 1 to n minus 1, that is that by I have to step from 1 to 3. So at 2, this will step from 1, 3 to n minus 1 like that. And also I have to change a bit here, 4, so it will calculate the odd terms, some odd, and another for loop. Even for even, I have to start from 2, 4 to n minus 2. So first term will be 2, and also step will be 2, and last term will be n minus 2, and I have to multiply with 2. Then it should output the result in Simpson's 1/3 rule. We put the function this, lower limit 0, upper limit 4, and trapezium number 4. It is 21.33. Somehow it matches with the analytical answer. For other problem it may not matches, but it will give more accurate result than trapezoidal rule. Now come to Romberg's integration. It is an iterative method. We will approximate the integration using iteration. It will give more accurate result than trapezoidal or Simpson's 1/3 rule as we iterate more. So the concept is to use first calculate the integration using trapezoidal or Simpson's rule for a step size h, then for h by 2, then h by 4, or half the step size, and calculate this, and then calculate this integration using this formula, and as the result will get closer and closer to the exact result, and as the difference between two become within a tolerance level, we will stop iterating. Here we will take first the function input, then lower limit, upper limit, and the number of iteration, then calculate the step size, and take a matrix with initialized with 0. First of all, I will iterate from 1 to iteration, number of iteration, take h by 2 here, and calculate the integration using trapezoidal rule. I may use Simpson's 1/3 rule, which will give more accurate. For simplicity, I used trapezoidal method. Then store the result in the matrix. In a matrix, in this way, I get this part. Then I use iterate from 2 to number of iteration. So in this way, for first column, this column, I use this rule 1 by 3. So here multiply, this is the row number, if for this the row number will be this and column is one previous column, so column minus 1. Then I have to find this, so row will be one step earlier, so row minus 1, also column minus 1, and using this I iterate through all of them, and in the end I just showed the result. If we run the code, lower limit 0, upper limit 4, number of iteration let's say 3, so it also give exact result in just 2 iteration. I have used only 3 iteration, I may use just 2 iteration to get the so yes, it gave the exact result in just 2 iteration. All the code will be available in the description box.